Welcome to Practical Access. I'm Lisa Deeker.
And I'm Rebecca Hines. And Lisa is so excited about today's guest because he's the HLP wizard and much, much more. Lisa, who do we have?
Well, we have both a friend and a colleague, Michael Kennedy, who's a professor at the University of Virginia, and he's the co-editor of the Journal of Special Education Technology. So welcome, Michael. We're so excited to have you.
Lisa, Rebecca, thank you so much. Good to see you both. Looking forward to our chat.
Yeah. So since you are the writer of the HLPs, one of many in special education, we have a project where we're really trying to help people in math and science think deeply about how to do a better job in working with kids with disabilities. So I'm going to ask you kind of a question you've never been asked before. Which HLP do you think is the most important to start with if I'm a novice teacher working with kids in science and they have disabilities that I really should think about as I start my journey as a new teacher in science and special education?
Yeah. Well, I'll never not say explicit instruction. That perhaps the most predictable of all the answers. And I'll tell you why. It's because we think about explicit instruction as being one thing, and it's not. It's lots of things, using clear cues, using clear language, going out of your way to provide rich examples, modeling, providing guided practice, providing independent practice. And the use of explicit instruction and its components are going to help students with disabilities, multilingual learners, and all students receive information about very complex terms in science. A lot of times the words that we teach kids, meiosis, it means nothing. It has a very technical, we wouldn't be here without it, but it has a very technical definition. All of the words that you would use and find to define it need definitions themselves. And so a master of explicit instruction would go out of their way to be really specific about that nuance and think through, I can't just give the jargon. I can't talk about the prophase and the anaphase and the sister chromatids. I need to think about, no, this is cell division. This is how cells reproduce and how we're all here without getting too graphic about it. So there's my thoughts about that.
So I will ask you then, Michael, what do we do then? So when we're trying to explain meiosis in a way that it becomes situated knowledge for the learner, not just a vocabulary word to understand, can you expand on that a little more? I'm sure you've been in classrooms where everyone else hangs on to it, but you've got a few kids who are really struggling. How are we going to help those students have even another layer?
Yeah. I think the most important thing, Rebecca, is personal connections. We're not great at this. We in special ed are generally pretty great at this because we're always thinking about how can I relate this?
Right.
Because a lot of times we don't know.
Right.
I work in science. I don't know anything about science. I don't know I know a little bit. I know enough to be, appropriately conversational about it, but I don't know half the words that my team, we create these materials all the time that we're giving to teachers to use and kids to use and families to use. I have no idea what these words are, what they mean. They might as well be in a different language. And so the use of vivid images this is what it looks like, just showing a cell pulling apart and creating two, that means something. Like, you could just sort of see it. And then here's the personal thing, photosynthesis. It's do you like that air you're breathing right now? That's this, the result of this process. So personal connections, images, and then at first exposure, using language that students are prepared to understand. You can just say it's cell division. It's the plants using the sun's energy to make its food. which a byproduct of which keeps you alive. I know we can't hide from the technical full definition a lot of times because, that's they need to know the more technical. They need to talk about the ATP and the, all of that. But if they don't have anything on which to attach that, right. That's why I say the sure. Student-friendly language, the use of examples, the use of images, and then repetition. We're horrendous in teaching. We think you got the measles inoculation when you were a baby. I didn't get measles. Okay, we're good now. It's not like that with teaching. I said it once, you must have heard it. Therefore, you learned it. Let's move on. I'm not saying it again. If you didn't learn it, that's on you. We just can't do that. We really have to be strategic about giving kids information over and over again in ways that they can grapple with.
So, I would be remiss if I didn't take you on in a positive challenge. And for the listeners that don't know us, we're very good friends. So I know I can do this. And I 100% believe in explicit instruction, and especially for kids who struggle with language and vocabulary. But help me understand that balance, because I know you respect that balance too, yeah. Of student discourse, which is the core value in the 5E learning cycle model in science. Where does this explicit instruction of vocabulary and that need for kids to have those personal connections? Because I always say, in social studies, the vocabulary is not as hard because it's about humanity in most cases. Whereas I've never been a plant and been through photosynthesis. So there's always that struggle, yeah. As you said, to personalize it, which I loved what you said there. So how do we balance that I want kids to be in a group and have discourse, but I struggle with language, and yet I need to be taught the language. How do I do both at the same time and not go, one
yeah. Yeah. Well, thanks for mentioning history for one, because remember, the word revolution means something quite different in history and economics, absolutely. But over in science, it's kind of talking about something else. So we set kids up in a lot, just our wonderful English language. It's full of words like that are confusing to students, especially our multilingual learners. But no, you're absolutely right. And this is an appropriate challenge. And every time I write a manuscript and submit it to a science ed journal, this is coming. Or if you submit a grant proposal to the National Science Foundation. And it's the right question. Because as I said a minute ago, we can't hide from the rigor of this. We shouldn't. And we shouldn't hide from the disciplinary norms, as you alluded to. We want kids to act and function as scientists in order to appropriately engage the content. But students aren't in a position to do it until they have this base understanding, and then they've got a puncher's chance. So what we like to do in our science work is we'll front load the explicit instruction, because the science teachers don't really want to spend that much time on vocab anyway. It's not really in their training through teacher ed. It's nothing they're interested in. But if we can give them these materials that are pre-made, which is what we do in our lab, and we're using AI to do it now, which is cutting our production time in not even in half. It's amazing what's possible already, and it's getting better all the time. So if we can make evidence-based practices using the principles of explicit instruction, using these images, using repetition and built-in questions, all the things that we know are very effective for kids with disabilities, put those in the hands of the general ed teacher to use, or actually that's a special ed teacher could do that. That's one of the ways we're helping to get co-teaching to happen, because a lot of times in the secondary setting, the SPED teacher doesn't know what to do because I don't know the stuff, but they can learn the vocab. So either whichever one, do that. And then we are building in simulations, we're building in demonstrations that do what you're talking about, because science is supposed to be touched and smelled and grappled with in interesting ways. And we want that. That's exactly what we want. We just don't want to throw kids into the pot and say, try to figure this out. For kids that have an intellectual disability or autism or some other disability that's cognitively facing, that isn't going to allow it. They might like it. They might enjoy it, but throw me a question about it afterwards, I might as well not have been there. So that's why it's almost like a flipped approach, but I wouldn't trust that the kids would pick it up not in class.
When you look at information processing in general, and everybody sits and consumes in the classroom that short-term, event, but if there's not rehearsal, as you said, it's never stored. So I'm going to be I'll be the intermediary between Lisa's original point, and that idea that the word needs to be said many times by many people in the classroom. And sometimes for me, it's been in a co-teach setting, and I might be the special educator, and I might say, you know what, I'll own vocab in here. I'll bring it up. I'll use the word. I'll count how many times we use that word until we get to a really comfortable spot where the kids start remembering the word better. And I think that's kind of, what you're getting at there. So, Michael, I know you've done work in all different areas. So not just the vocab piece. What do you think for young teachers or new teachers? What do you see them struggle with the most when supporting kids with any kind of difference in science?
Yeah. I wish we did more in our work in teacher ed. I wish we did more in professional development and just talking about the basics of cognitive load theory and helping remembering ourselves, because I know we know it conceptually, but we don't talk about it. But we don't talk about it with our teachers nearly enough. I have a presentation I give on this, and the title, it's rhetorical, is Are We Talking Enough About Cognitive Load? And the answer is no. And the issue for young teachers, for all teachers, is we're all burdened with being alive. By that, I mean, we're worried about our finances. We're worried about my knee hurts. We're worried about my mom is sick. We're worried about life. Then throw into the mix, okay, now I've got this ridiculously difficult job to do with 22, 25, 30 students at a time that all have their own unique cognitive needs. I'm teaching content with which I may not be fully comfortable. I mean, if I'm a scientist, sure. But if I'm me, I'm making it up. Now I'm reading what I can to stay afloat from moment to moment. And then I'm using these teaching practices with which, if I've never used them before, everything is going to be a heavy cognitive load. And so as I think about how that impacts students, it's sort of easy to see the impact on them. As kids get overwhelmed in any given moment, and then they stop paying attention because they're not willing to pay attention to something that's frustrating them. They don't like feeling that way, so they don't. They just shut off. And some kids kick the desk over, and other kids put their head on the desk. Either way. For teachers, it's similar. This is one of the reasons why so many teachers leave, is because I hate feeling like a failure every single day. I'm not going to keep doing something, I know I'm getting paid and there's benefits here, so people stick it out. But there's lots of ways to do that, make money, get benefits. So as I think about cognitive load and its impact, it's really paramount. And so managing that for the teacher is really difficult. And that's at the core of our work. This is one of the reasons why, like if you go to vocabsupport.com, you'll find over 200 slideshows for science words made. And here you go. Because, you can change, if you don't like the definition, change it. You don't like the images, change them. But here you go. And what we find is our newer teachers or out of area teachers, you might as well be handing them, the King James, right. Or fill in with your favorite holy book. And our veteran teachers will say, oh, I can see what you're going for here. I've got slides that are like this, but I'll plug this in too. And that's where we learn really interesting things. So managing cognitive load is well beyond just vocabulary. It's something that we really need to be paying more attention to in our field.
So our last question, and I love that it's cognitive load, and it's going to lead to a weird spot, but it's one that I would love to get your thoughts on. So there is some emerging research that shows that smell and taste lay closest to the sensory part of the brain where long-term memory is stored. And I love that you mentioned pictures and movement. I'm curious what you would tell me as kind of your parting thoughts here. If I've got 2 minutes And that's all the time I can squeeze in before the kid has to go to a group and do. So like, where do I start? There's so many things I could do, but let's take the word photosynthesis. You're right.
Yeah.
You know, the word photo means something in one world, photosynthesis means something else, and synthesis means, you know, where do I start? What would be your kind of your parting thoughts of, all right, Lisa, new teacher, do this before you do anything else?
Yeah, I would track down what we call an anchor image for each. That's going to be the main image that you utilize over and over again. If you see tree, you see plants, you're thinking about photosynthesis. I would think about the language that's going to define it without needing other words that need defined themselves. And I'm going to get an army of examples. So often we just say, yeah, an example of that is some throwaway thing, and then let it go. No, we want to teach the examples. We want to explain, this is an example because, and then do multiple ones. And let kids talk about it. Let them come up, hey, could you think of one? And that's not always possible. Like, you know, some things we teach, there isn't anything obvious. And so that we need to do more work in those circumstances. But a lot of times there are, and science lends itself to this, especially in the physical sciences. There's so much for kids to go and find or touch, or I can find for them if they can. But just popping on a video, that's not it. You know, just talking about it or giving a lecture on slides, that's not it. So we really need to be deliberate and thoughtful about this. And it takes a little bit more time, sure, but the payoff is the better engagement, which then breeds better engagement. And when we have a classroom full of struggling kids that are tired of me talking, 180 times of that is going to be a recipe for not much learning and not setting them up for being interested in the next year's science and then the career potentially in science. So stop talking, get them seeing it, touching it if they can, talking about it. I love that writing about it would be a gift for kids. There you have it.
All right. Well, thank you. Some great advice and exactly what our listeners need to hear about science vocabulary. So thank you, Michael. And if you have questions for us, please send us a tweet at Access Practical or post a question on our Facebook page at Practical Access. Thanks again, Michael.
Good to see you both. Thanks for having me.